Lesson 12 Summary. We can divide circles into congruent sectors to get a sense for the size of an angle measured in radians. Suppose we want to draw an angle that measures 2 pi over 3 radians. We know that pi radians is equivalent to 180 degrees. If we divide a sector with a central angle of pi radians into thirds, we can shade two of them to create an angle measuring 2 pi over 3 radians. So basically what this is saying here is that a nice way to think about radians is fractions of a circle. Half of the circle is pi radians, so if I want something to be 2 pi over 3, we're cutting it into thirds and taking two of them. Another way to understand the size of an angle measured in radians is to create a double number line with degrees on one line and radians on the other. On the double number line in the image, the degree measurements are aligned with the equivalent radian measures. For example, pi radians is equivalent to 180 degrees. And what's interesting about the relationship actually between degrees and radians is that we have a function that we can use to convert from degrees to radians and vice versa. So if you think about it, if we're going from degrees towards radians, let's say here we're starting off with 180 and we want to get to pi. Well, you got to think about what could I multiply 180 by that would equal pi, right? So really they're saying 180 times some number y or some constant is going to equal pi. So to find that number, we're really just trying to get y alone. I can divide both sides by 180 and we just get y is equal to pi over 180. So what that is saying is any degree measure multiplied by this right here is going to give you the result in radians. If we try 360 times pi over 180, (360) and 180 are like terms, so I can actually divide them. 360 divided by 180 is 2. So that's going to be 2 times pi. So if that works for both of these, that's always going to work. And of course it works for 0 because anything times 0 is just 0. So that's a good thing to know. If you're converting from degrees to radians, obviously we talked about how you can think of it as a partition, but you can also just multiply it by some constant here, pi over 180, and that conversion will work as well. The same thing we can do converting from radians to degrees. Let's say I know I have pi radians, and what I'm trying to find some number I can multiply pi by to get 180. Do the same thing. It's actually going to be an inverse function, which in this case is also a reciprocal. So if we're converting from radians to degrees, we can multiply our radians by 180 over pi. So let's demonstrate that with 2 pi to 360. I have 2 pi times 180 over pi. Pi and pi will cancel out. Then I've just got 2 times 180, which is equal to 360. All right, so let's continue. Suppose we need to know the size of an angle that measures 3 pi over 4 radians. The left half of the double number line represents pi radians. So they're saying from here to here, we have pi radians total. Divide the left half of the top and bottom number lines into fourths, then count out 3 of them on the radian lines to land on 3 pi over 4. So they're saying we're going to cut top and bottom into fourths. So basically, if we break this into 4 parts, right, each are going to be 1/4 of the total, which is pi. So this first one will be pi over 4, 2 pi over 4, and then 3 pi over 4. So right here, that's what we're trying to find out, what that degree measure is. On the top line, each interval we drew represents 45 degrees because 180 divided by 4 equals 45. Just like we divided pi by 4, we can also divide 180 by 4 to find the total. So this is really pi over 4 is 45. And then if I double that, right, that's another 45 equal to 90. Another 45, 135. And then another 45 would bring us full circle, or technically half circle, to 180. If we count 3 of those intervals, so that's right here, 3 intervals, 1, 2, 3, we find that 3 pi over 4 radians is equivalent to 135 degrees because 45 times 3 is 135. So that's a nice way of looking at it visually. That's how I actually tend to do it. I really try and break up. If I see I've got 3 pi over 4, I'm thinking, okay, 3 over 4 is less than 1, right? And this is like 1 pi. So I know I'm going to be less than 180. And I want to break that 180 up into 4 parts. So just dividing 180 by 4, multiplying by 3 is another way of thinking of it. If we want to use this method I was showing before, where I know I have 3 pi over 4 radians, and I want to convert from degrees into radians, I want to convert from radians into degrees, I can just multiply this by 180 over pi. Pi and pi will cancel out. And then you can see what we're really doing here is multiplying that 180 by 3 and dividing by 4, which is technically the exact same thing you're doing up here. 3 times 180 over 4. What's 3 times 180? 540 over 4. And that's equal to 135. All right, so a couple different ways you can convert from degrees to radians. I like this a lot, especially if you're someone who doesn't love fractions. It can be made a lot clearer if you just sort of write them out and have a easy conversion right there. All right, and if I were to continue this, right, if we're thinking about fourths all the way, if I add another 3 pi over 4, and then we just have pi, which is really 4 pi over 4. We could continue this to 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 2 pi, which is really 8 pi over 4. And do the same thing with the degrees. Plus 45, we get to 225. Another 45 would bring me to 270. Another 45 brings me to 315. And then we get to 360. All right, so a lot of different ways to look at it. Hopefully this is all helpful. All right, that's all for lesson 12.